So today's lesson is on describing functions, and there are two categories to describe a function. A function can be linear or nonlinear. Linear refers to a straight line. That line can go uphill like so, or the line could go downhill. Just kind of draw a downhill line like this. The line can go horizontally like that, or the line can go up and down. So these are different types of lines directionally. Um, a function can be nonlinear, meaning the graph is not a line. So this, it can have a curve or any type of change in direction. It is also important to remember that you can determine if a function is linear by looking at a table. For example, on this table, we've done this in class before. As you can see, if you can establish the change between each x as being the same amount and the change among each y value in the table, then that's considered constant. So that table would be linear. Um, if a table, when you are looking at the change between the values in a group, for example, the x values are all constant. However, on the y value side, they're not constant. So this table would be a nonlinear table. Looking at equations, a function can be linear just by looking at the equation. And what you're looking at is your variables, the y variable and the x variable, to ensure that there are no exponents above those letters. In contrast to equations where you do have a variable, like here, y equals x squared, because the x has an exponent above it, that would be considered nonlinear. At the bottom is some other criteria you can look for the linear equations rules versus nonlinear. The last two labels that you can describe a function with is proportional and non-proportional. If you notice with proportional, 0, 0, if you can visualize it inside of the actual word itself, in proportional. If a function is proportional and it's in a table of values, that table will contain 0, 0. If a function is proportional and it is a graph, you will automatically see it because the graph will some kind of way touch the origin, like here. If an equation is proportional, it will be in y equals x form, and there's nothing on the other side of x. So this is the form y equals some number in front of x, but nothing behind it. This is an example of a proportional type of equation. When a table is non-proportional, just looking at the word non-proportional, that means there's no 0, 0 involved in any question type. So for example, in this table of values, when you're looking at the ordered pairs, there is no 0, 0 ordered pair. So this table would be considered not proportional. Graphically, a non-proportional graph, when you trace it to the y-axis, it will not touch 0, 0. So 0, 0 is not included in non-proportional graphs. They do not go through the origin. And lastly, in the equation form, the non-proportional equation form will always have a number behind your x. And we'll talk about what these numbers in front of and behind x mean. So as we work through the describing functions word problems today, please refer to these reference pages. Okay, so go ahead and look at your paper describing functions, and we'll go through some word problems on graphing linear functions. In this word problem, it's talking about the temperature at dawn was 8 degrees Fahrenheit, and it's increasing steadily at 2 degrees Fahrenheit every hour. So in your table of values, it gives you the equation y equals 2x plus 8. And the temperature is represented by y, because that's the label on your y-axis. And your time is in hours, and that's on your x-axis. So that's very important to know in word problems what category is representing which variable. So as you can see, I've in all representations, I've color coded the Y category on the graph, and then the X category on the graph in green. Y is in yellow. And as you can see, with the plotted points that were given on the graph are based on the input values from the table. So when X is 0, Y would be 8. When X is 2, notice the interval here is counting by 2s, 2, 4, 6, 8, and so forth and so on, and as well as on the y-axis. Always look at your counting interval. But these points are represented here in your table. If I did not have a graph, then I could use Desmos and input the x-axis into the function rule here to get the ordered pairs. So everything lines up. So the question is this relationship between the time and the temperature proportional or non-proportional? And so because we have an equation in the word problem, you can base your decision on looking at the equation form. Which equation form represents y equals 2x plus 8? Would it be the proportional kind or the non-proportional kind? I could also base this on the graph. That would be another easy way to base it. Is the graph going through the origin to be proportional, or is the graph not going to the origin? So you decide and circle here, circle your answer. Okay, so on this next example, example 2, you're determining whether the function is linear. And so the word problem reads, a square tile has a side length of x inches. The equation is given, y equals x squared, gives the area of the tile in square inches. So we have two representations. We have a table of values, and we have a graph for this question, and we have the equation. And you're determining, based on what's embedded in the table, the graph, or the equation, two different distinct things. Is the relationship linear or nonlinear? And then is it proportional or non-proportional? Now, most times, if you determine that a relationship is linear, then you determine if it's proportional or non-proportional. So with that being said, we could look at the equation form and compare over here. Let's go back to, or flip your paper back to the linear, nonlinear side. Okay, so looking at the linear versus nonlinear reference sheet, based on the equation, what would be your decision? Is the equation linear? or nonlinear in form. You could also base it on easily on the graph. Is the graph linear or nonlinear? Please circle your answer. If your answer is linear, then you tell if it's proportional or non-proportional. Okay, and just to finish up on the back side of this page, you have about 4 your turn questions. Please use your reference sheets on proportional, non-proportional, linear, non-linear to help you with whatever the question is given. So for example here, state whether the relationship between x and y in this equation, y equals 0.5x, is proportional or non-proportional. Look at the proportional or non-proportional reference page and find the equation type. Whichever equation type matches this one, write proportional or non-proportional here. On the next question, it is a word problem. A soda machine makes 2/3 gallons of soda every minute. The total amount Y that the machine makes in X minutes is given by this equation. So we have a function rule, and it says determine whether the relationship is linear. So you want to look at the linear or nonlinear reference side of the page. Look at the equation. You do have a blank table here to complete. For this, you will want to use your Desmos calculator. Type in the rule, 2/3 x, and replace with these given values to get your outputs here. Once you have all of your data completed, then you will plot the points here to actually see the graph part. So if you're given an equation, plug the rule into Desmos, especially when you have blanks on your table. Okay. Based on your graph or your table, check your linear, nonlinear sheet and log if this is linear or nonlinear. You only have to say if it's proportional if you determine that the relationship is linear. And your last problem is very similar to this problem, other than your table is completed and you're basically graphing the relationship and making your determination. Please make sure that you write in your answers to get credit for this in all of the blank areas, or in all of the starred areas.